I'm going to show you this new way. So you still do have to divide by 2. So you have to make sure your R still is in like this form, okay, where your coefficient is 1. So you guys said our R would be -1/2, right? All right, so then I'm going to leave all this as is. I'm going to plug in a 6, a 1, a -3, and a -1. And then we're going to do synthetic just like we always would, okay? So then this would be -3. Add those together, it's -2. Multiply, and I get 1. Add, and I get -2. Multiply, and I get 1. So this has a remainder of 0, okay? Now, here's what you have to do. In your final answer, since I only simplified the right to get it started, I'm now going to simplify the left to keep this equal. So I would take all of this and divide by that coefficient of 2. So I would have a 3, a -1, and a -1. So my final answer, then once I put the variables to it, would be 3n squared minus 1n minus 1. Okay? Now, the piece to this that you need to make sure you know is if you would have gotten out a remainder, so let's just pretend that this was a remainder of 2. If you get out a remainder, you do not divide by that coefficient. And here's why. Because, remember, I don't know if you had one like this in your homework, but remember in the notes the one that we got out where your remainder looks something like, I don't know, who cares? Something like this, right? And so in the end, you had to keep change flip anyways to get rid of that fraction, right? Does everybody remember that? And if you look at your notes, which you need to get them out anyways, can you get out your notes from last time? Because I want you to tell me on that synthetic problem that we did like that, can I borrow yours to look at the problem? So I'm going to write what the original problem was, which it was this, on that last page, or second to last page, I guess. Okay? And what was our remainder the first time we did it? -2/3? Okay, so in your final answer originally, we had -2/3 divided by x plus 1/3, right? Which we couldn't do. We had to keep change flip. And so what did the remainder, what did it become once we did the keep change flip? Yeah. What does that 3x plus 1 match? The original one. So really all you ended up doing with your remainder looked like this. You started it by dividing by 3. If you would have taken that back through from the get-go, right, now my remainder is just -2 from where I started. Okay? So in this case, you didn't have to change anything about these coefficients because you did it here, but I did have to fix my remainder, right, because I took it out from the original. Going the reverse, like we just did here, maybe, if I do not take the coefficient out from the left side or from the main piece, then I just have to do it at the end, and I do not have to worry about my remainder, because my remainder will fix itself in the end. Okay, is everybody with me on that? So you can do it either way. I think the nice thing about this way is that you don't have to worry about your fractions throughout. It kind of takes care of itself. Okay, so do I have any questions about that for synthetic? Okay, so keep those notes out because we're going to look at 2 problems that I want to make sure we know how to do from these notes. So this is on the last page of those notes from last time. And we're just going to do these 2 examples. So you can mark out the ones at the top I think those are the ones at the top. These are at the bottom, right? So the ones at the top are pretty simple, like I'm asking you to evaluate f of 2. So we know when we say evaluate, just to make sure we're clear, everybody knows that that means I take that number and I plug it in to the function. Okay, so we're just going to look at, this is more like what you're going to be asked to do. So I'm going to say I want you to evaluate c of y cubed. So I'm going to take the y cubed and I'm going to plug it into my c function everywhere that I see an x. Okay, so we're going to have 4, and make sure when you plug in you're using parentheses. Y cubed to the third minus 5, parentheses y cubed to the second plus 2. And then we're just going to follow order of operations. So we're going to do exponents first. So what's y cubed to the third? Y to the ninth. Good. Remember, you multiply exponents when you raise a power to a power. Then you can just bring down that 4. What do you get when you take y cubed to the second? Y to the 6th. Then I can bring down that negative 5. And then I have my plus 2. Can I add or subtract either of those? The answer is no. Why not? Yeah. They don't have the same exponents, which means they're not like terms. So we are done. So most of the time when you evaluate and you plug in a number, you get out a single number. If you're plugging in a variable, then you're going to get out some type of polynomial in the end. Okay? Anybody have a question there? All right, now let's look at this one. And it's important that you're reading this correctly. So can somebody tell me how you would read that, what I'm asking you to do? How would I read that? Lucy? Okay, so this is saying what is negative 4 times, right? That negative 4 is on the outside, it's squeezed, times d of 3z. So I'm going to take my 3z, and I'm going to plug it in everywhere I see an x into that d function. And my negative 4 is going to go on the outside of all of that. So I'm going to put my negative 4 out here, and then I'm going to plug in my 3z into that d function. Okay? So that would be 3 parentheses 3z squared plus 6 parentheses 3z minus 10. And then you're going to do your order of operations. So we're working inside the brackets first. And inside those brackets first, I need to do exponents. So what is 3z to the second power? What are we missing? Nope. 9. Take it into both, right? 3 squared is 9, and then z squared. So I have 9z squared. Then I'm going to bring down that 3 out in front. And then over here, we can just go ahead and multiply those, right? What's 6 times 3z? 18z, and then I can bring down my minus 10. Still have these brackets, so don't lose those. Bring down that negative 4 out in front so I don't forget that. Then I'm going to go ahead and multiply inside my bracket again. What's 3 times 9z squared? 27z squared. And then I'll bring down plus 18z minus 10. Can any of those inside that bracket be added together? No, they're all separate. So from here, you're just going to take that negative 4 through, and that's going to be our answer. Help me out. What's negative 4 times 27? Negative 108 z squared. Okay, negative 4 times 18. And then negative 4 times negative 10. would be positive 40. Okay? Anybody have any questions on that? Yeah. You're thinking of standard form for linear functions. So A, yes, that's a great question. A is fine to be negative for polynomials. That's just linear stuff. Okay? Anything else on that? All right, so we're going to move to 5-5. Okay, so here's what we're going to do in 5-5. You're going to learn today how to solve and factor polynomial functions. And up to this point in your math world, you really have only solved quadratics or factored quadratics. You've never had to do anything higher than an exponent of 2. Okay? So first thing is there is a special case. And this special case is called sum and difference of cubes. And this is something you're just going to have to memorize, okay? And what that means is the following. If I have 2 cubes that are being added together, then I can factor it down to look like this. And this is the memorized part, okay? So how do you know if something is a perfect cube or not? Does anybody know a perfect cube? What does that mean to be a perfect cube? Okay, you get, do the cube root of it and you get a whole number, yeah? Why is 8 a perfect cube? Yes, so 2 times 2 times 2 is 8. 1 times 1 times 1 is 3 times 3 times 3 is 27. 4 times, okay, and so on. So that's how you figure out if something is a perfect cube. On your calculator, do we have calculators ready here? Want to make sure we all know how to do a cube root. So on your calculators, you're going to hit the 3 and then the second, is it the caret button? It's going to be the button that looks like this. So you want the button that's giving you a variable right there because you're telling it what you want it to do for the root. So you'll hit 3, second, and then just try something, like plug in 8. Make sure that worked. Did you get out 2? Okay. So if we had, so you could always check and see, is it a sum of cubes or is it a difference of cubes by taking the cube root of those numbers and seeing if it is, in fact, a perfect cube, okay? But this is the formula. So let me just say this right now. There's no rhyme or reason. It's that you have to memorize it. You're just going to have to memorize it. Here's the only difference. I want to point this out. If it's a sum, you put a plus sign here and a minus sign here. If it's a difference, you put a subtraction sign here and addition sign there. That's the only thing that is different about a sum and a difference of cubes. Okay? All right, now, we're just going to look at these examples, and we're just going to factor them. Not every polynomial can be factored. So if it can't, it's a prime polynomial. And if it can't, we'll just say it can't be factored. Okay? So let's look at the first one. Remember, when you factor, you're trying to pull out anything it has in common. So what could you guys pull out of this first one? Does anybody see something? What do they have in common that I could take out? A 2? Anything higher than a 2? Does 4 go into 54? Okay. So is 2 the highest coefficient we can pull out? Okay. So let's take out a 2. Is there anything else I could take out? They both have an x. Okay, so let's take out an x. All right, so when I do that, I divide by a 2x. What do I have left in my first term? 8x cubed plus 27y cubed. Okay. All right, now, up to this point, you guys would look at this and you would say, okay, those don't have anything in common, so I'm done. And this is just going to take practice, that you need to recognize, here's a hint, if I have exponents of 3 here, what do you think they're trying to get us to think through? Exponents of 3, cubes. So the question is 8 a perfect cube? Yes. Is 27 a perfect cube? Okay, so this is a sum of 2 cubes. So we're going to use that formula up above, which means we got to break it down. So the formula up above for sum is you're going to have a binomial with a plus sign, right? And then I'm going to have a trinomial, and I'm going to have a minus and a plus, okay? And then if you look at that formula, the formula was a cubed and b cubed, but we pull out what a would be and what b would be, which means you're taking this value and you're cube rooting it. So what would I get when I cube root 8? 2. What do I get when I cube root x cubed? X. Then do the other side. What do you get when you cube root 27? 3 and y cubed. Y. Okay, and then from there, in the formula, the next part is I put in a squared. So I go back to my a, right? My a is 2x. So what's 2x squared? What'd you say? 4x squared. Good. And then the formula says a times b. So I take my a and my b and I multiply them together. What's 2x times 3y? 6xy. And then I take my b, 3y, and I square it. What do you get when you square a 3y? 9y squared. And then you're going to bring down your 2x. Okay? And here's what I want you to understand. So this is going to be it right here. That's a square. I don't know why that's, there we go. The thing you need to know, so I'm going to put it up here so we can see, these trinomials right here are not ever going to be factorable. So once you get down to breaking down the sum or difference of cubes, that trinomial you won't be able to do, you know, where you multiplied like a times c and you said, okay, what factors of 12 add to give me 8? It's never going to be possible. Cannot factor it. So that's how you know we're done. So we broke down this. This trinomial right here cannot be factored, so we're done. Okay? Anybody with me on that? Any questions there? All right, so let's try the second one. What does 8y cubed and 5x squared, or 5x cubed, have in common? Is there anything I can take out before we start? Okay, there's nothing I can take out. So the only other option, if there's nothing to take out, is this a sum of 2 cubes? And why are you saying no, Bailey? Whole number. Yep, good. So 5 is not a perfect cube, so this is not factorable. It would just stay just like this. I guess we're supposed to write prime. Whoops. So that's a prime polynomial right there. Okay, let's try B. Is there anything we could take out to get started? Yes? What do you see? A 2? Is there anything higher than a 2? Anybody? Is that the highest? Yeah? 6 doesn't go into 250, I assume? Okay. And I would, since they're both negative, I would take that out with it. So let's take out a negative 2. Anything else that they have in common that we can take out? W. All right. So I would have left 27 W cubed plus 125 Z cubed. Okay? Now, are those, so I see that exponent of 3, are those perfect cubes? They are. So we're going back to do the sum of 2 cubes, okay? So here we go. Let's start with our binomial. The binomial is going to have a plus sign, right? It stays exactly what the sum or difference is. If it's a plus, it stays a plus. If it's a difference, it stays a minus. All right, let's cube root the first term. So what would my A be when I cube root 27W cubed? 3W. What will my B be when I cube root 125Z cubed? 5Z. All right, now you're doing your trinomial. The first term is A squared. So what's 3W to the second? 9W squared. What sign comes next? Minus. It's the opposite of whatever you have here. And then remember, this is A times B. So you're taking 3W times 5Z, and that is 15WZ. The last sign is always a plus because you're squaring it. And what do you get when you square 5Z? 25Z squared. And then I bring down negative 2W. Can I factor that trinomial right there? Can I factor that? No, remember, always the answer is no. It's non-factorable when you do sum and difference of cubes. Non-factorable. Okay? Any questions about that? Okay, so that's one method for factoring. Here are some other methods. Okay? So first, you can always take out a GCF if it's possible, which we did that on 2 of them. So you always want to recognize, is there a GCF I can take out? Then we want to do that. We already did sum and difference of 2 cubes. Just make sure you remember this. Some of you forget this, I think. Difference of 2 squares, you need to remember that that is factorable always. And it looks like this. So for example, if you have this, x squared minus 4, that's a difference of 2 squares, right? Exponent of 2 is a square, and a 4 is a square. So this would factor into, based on what you see right there, what would that give me? How would I factor it? X plus 2, x minus 2, yes. So pay attention to perfect squares. Don't just get caught up with cubes. And it only works for subtraction. So if that were x squared plus 4, you can't factor it. You're done. Just stays x squared plus 4. Okay? Okay, then we have 3 terms. You guys already know this. 3 terms, so trinomials, you just do the factor method like you've always done, where we would multiply first and last, find factors that add to the middle term. That one you already know, so that's not a new concept. This part is new. If you have, because you've never had to do this, you've always had trinomials, if you have 4 or more terms, you're going to want to do this grouping method. And you're going to see how this works, so we're going to practice it, where you're going to put things together that go together and have things in common. Okay? So we're going to try this. So we're going to factor each polynomial. If you can't factor it, you're going to write prime. Okay? So here's my suggestion. The second I see more than 4 or more, I'm automatically going, can I group these together so that they have anything in common? Okay? So here's what I mean by that. If you guys look here at these first 3 terms, do those look like they have something in common? What do they have in common? X, what else? A 4 and an X. Okay, so let's just go ahead and group those together. And do the last 3 look like they have something in common? Okay. Juliet, make sure you're writing this. So I'm going to go ahead and take it out. So if I take out a 4 and an x of the first group, what would I have left? 2a plus b plus c. Now, this is only going to work if, when I take something out over here, my parentheses match. Grouping only works if the group that you create matches each other, okay? So what can I take out of this second group? 3y, all right. What would be left? Good. Do my parentheses match? Okay, so since they do, then I bring that down, and then what's left over goes inside the parentheses, 4x plus 3y. And if I can't factor any further, then I'm done. And so really what you're looking at is here, when you have two terms, you're looking to see, does it have anything in common? Is it a difference of cubes or a difference of squares or a sum of cubes? So is that a sum of cubes right there? 4x and 3y, are those a sum of cubes? No. So I'm done. That has been factored. Okay? All right, I want you to try the next one. Find somebody around you to talk it through if you need to, and let's see what we get on this one. And you can check your answer with somebody as well. And I hope you're seeing you might have to rewrite this to get things that have stuff in common together. Did we get this answer? So as you're finishing up, take a look up here and see. It doesn't have to be in that order. You could have had 5y minus 4z times 4x plus 3g minus 2h. Again, the order doesn't matter. Does anybody have a question on that maybe didn't get that, or you don't know where you made a mistake? So did everybody see that I rewrote this so that I could put my terms together that had things in common? So you might have to rewrite your polynomial to get your stuff together that matches, okay? Okay, I want you to turn the page. This time I want you to find somebody beside you, and I want you to talk this one through. and then come up with your answer. If there's 3 of you around each other, that's fine too. But talk it out and see what you come up with. So I'm hearing some good discussions. Okay, so can you group them and they have something in common? Your groups, okay? Which is great. Does that mean it's factorable? So what's the issue you're running into? Okay, so once you took out a GCF from the groups you created, you're saying your parentheses do not match. Is everybody having that same issue? Yes, you are, and so what does that mean? This is prime. Can't be factored. Okay, so sometimes that's going to be the case. Okay? All right, so now we're going to look at an example where I am giving you a difference of squares and difference in sum of cubes is also going to play a part because I want you to recognize this. So we want to factor this polynomial right here. Okay, it's 2 terms. If you go back to the front page and you look at that table where it says 2 terms, you have 3 options, right? You have a difference of squares, a difference of cubes, and a sum of cubes to be able to factor. Does everybody agree with me on that? Okay. So here's the deal. If any time it's a difference of squares, you have to start there. So you got to start with your smallest first and then work your way. So the question is x to the 6th, would that be considered a perfect square? If you're not sure when you're dealing with exponents, if it's divisible by 2, if the exponent is divisible by 2, it's a perfect square exponent. Is 6 divisible by 2? Yeah, okay. So I can make this, so this is difference of squares. So we're going to use that formula, which remember, you have 2 sets of parentheses with a plus and a minus. Again, if you don't have this memorized, you can look on that table. And you are plugging in what your A and your B would be, which is the square root of x to the 6th. So what would the square root of x to the 6th be? X to the 3rd. What would the square root of y to the 6th be? Y to the 3rd. And here's why you had to do the squares first. Because now, what do you notice about those 2 terms and those 2 terms? They are cubes. They have an exponent of 3, so they are cubes. So now, I'm going to do the sum of cubes, and on the other side, I'm going to do a difference of cubes. Okay? Are we ready? So sum of cubes. Remember, you have your binomial, then you're going to have your trinomial. Okay? And the binomial is your A and your B. So you go back up to your original, and I just cube root those. So what's x, the cube root of x cubed? X. Cube root of y cubed. Y, what sign goes in there? Plus. Good. Then my trinomial, I take my A, which is x, and I square it, which is x squared. What's the sign? Minus. And then it's A times B, so take your x and your y and multiply them together. xy, always a plus at the end. Take your B and square it. Y squared. All right, now we're going to do the same thing, difference of cubes. You do your binomial and your trinomial. This is going to look identical to the green one, except what is going to be the difference? Wiley? There'll be a minus sign in the first. Good. There'll be a plus sign for your middle term. All the trinomials that we got, can those be factored even further? What? The answer is no. So that's, again, you got to memorize that. Sum and difference of cubes, those can never be factored further. That is my final answer in factored form. Okay? Anybody have a question there? All right, so let's look at B. How many? Yeah. Into the what? No, you're literally just following that formula on the table. So there's no distributing. You literally just, sign stays the same for difference, and then here it always becomes a plus sign. Yeah. Anything else? Okay, so now if you look at B, how many terms am I giving you? 6, even if you just said a lot, okay? Anytime you see a lot, you are automatically trying to group these together to see if you can pull out a GCF, okay? So does anybody see anything, any groups that we can put together here or something we can take out? Yeah. A to the third? A cubed? Okay, what about the second? So you're saying this is a second group here? Okay, so let's take out A cubed from the first one. So we would have left x squared minus 6x plus 9, all right? And then what would you take out of the second one? What do they have in common, Bailey? Yeah, go ahead and take out that negative. So negative b cubed. So I would have left x squared minus 6x plus 9. Did that work? How do you know it worked? Good, the parentheses match. All right, so we can bring down x squared minus 6x plus 9, and then that leftover goes in parentheses a cubed minus b cubed, okay? Now what do you notice? Okay, what do we call this? Difference in cubes, yes, difference in cubes. Okay, so we can break this one down. So when you do the difference in cubes, you have your binomial and then your trinomial. Again, we're just following that formula. What's going to go in my binomial? A minus b. And in the trinomial, I will have a squared plus ab plus b squared, okay? And then I'm going to bring this down. And how do we know if we're completely done? So we know over here we're done, right? When you do sum and difference of cubes, that's it. Like, I can't do anything with that trinomial. But what about right there? Can we factor it? How do I know if I can factor it? What do I do? By 1. Okay, are there any factors of 9 that will add to negative 6? And negative 3 and negative 3. Okay, so that means I'm not done, and I need to factor that. Now, remember this. You do not have to rewrite this whole thing and factor it. Does everybody know that you can go to shortcut factoring if this is a coefficient of 1? So the shortcut is literally just put your x in the front and then take those factors and plug them in. Minus 3, minus 3. Okay? Now, how could I rewrite that right there? X minus 3 squared. And I won't count off if you don't do that, but in simplest form, that's really what it should look like. And then I'll rewrite the rest of this. Whoa. And then we are done factoring. Okay? Anybody have a question about that? Okay, so here's what's going to happen. I'm teaching you all the methods of factoring. I'm trying to give you an example of everything you might see. And now we're going to figure out how we take this and we solve. Okay? So we're going to come back to this. We're going to look at some solving ones. So here's what I have. My very first example here, I have a trinomial, right? You know how to factor trinomials. So the first thing I would always do is there a GCF that I could take out of this? Yeah. Okay, so let's take out a 3. So I would have 6x to the 4th minus 7x squared plus 1 equals 0. And then just so I don't have to mess with that coefficient of 3, how can I move that 3 to the other side? Divide. Yep, so I'm going to divide by 3 on both sides. And the nice part is, what happens to that 3 on the right side? Just becomes a 0. It's gone. Okay, so when I have a trinomial, I can look and see if it's factorable, right? So let's see. Multiply first and last. So I'm looking for factors of 6 that add to negative 7. Will there be any factors of 6 that add to negative 7? Negative 6 and negative 1, yes. Can I shortcut factor this one? No. Okay, so I'm going to rewrite 6x to the 4th. And then remember, I'm replacing, now notice I have different exponents, so you got to pay attention to this. I'm just replacing negative 7x squared with negative 6x squared and negative 1x squared. Okay, so it's just like you've always done. We just have some exponents here instead of just an x. Bring down your plus 1 equals 0. And this is why grouping works. Because you see when you rewrite it, you have 4 terms. You learned when now you have 4 terms, you group. You just didn't know that in Algebra 1 when you learned factoring. And then you take out what they have in common. What does the first group have in common? 6x squared. Good. So I would have left x squared minus 1. Second group, negative 1. So I have x squared minus 1 left. Okay. Then what do? Bring it down. So I have x squared minus 1 times 6x squared minus 1. And then what do I have to do? Set it equal to 0. Yes. I'm going to do that over here. So I have x squared minus 1 equal to 0. And I have 6x squared minus 1 equal to 0. So how am I going to solve that? Add 1. So x squared equals 1. Then what? Square root. So what will x equal? What are you missing? That said x squared equals 1. X equals plus or minus. Yes, remember you have two answers when you do the x squared and you square root, right? I could plug in a 1 and square it and get 1. I could plug in a negative 1 and square it and still get 1. Okay, so there's two answers. I'm going to do the same thing here. I'm going to add 1. So I have 6x squared is equal to 1. I'm going to divide by 6. Leave it as a fraction. And then we're going to square root, right? Which means this. Everybody with me on that? Square root the top, square root the bottom. So I know I'm going to get out a plus or a minus. Now, here's the only thing. Square root of 6 is a decimal, right? But you don't leave your answer like that. Do you remember that from Algebra 1? You can't have a square root on the bottom? What do you do if you can't have a square root on the bottom? What? Kind of flip it. Well, you multiply by itself, top and bottom. Do you guys remember doing that? So then on top, I would get square root of 6. And then what is square root of 6 times square root of 6? 6. That's the whole point. It gets rid of that rad. So I have plus or minus rad 6 over 6. Now, how many answers do we have right there? 4 answers. Why does that make sense? Go back to your original problem. It's to the 4th power. So when we had an x squared, right, and you solved a quadratic or you graphed a parabola, how many answers did you almost always get? Not every time, but almost always. 2, and it was where? Or where did your answers have to go? On the x-axis, okay? So could your answers be complex? Yeah, like you could get complex answers for quadratics. Same is going to be true for polynomials. In this case, will all 4 of those answers be on the x-axis? Yeah, because square root of 6 is just a decimal, right? So that graph would cross, so this is where it's going to get interesting, would cross 4 times. There's 1, 2, 3, 4. So you're going to start to see, and we're not into graphing yet, but we're going to get there, that your roots or your zeros are going to affect what your graph looks like. Okay? All right, so let's look at the second one. Now, before we do anything, how many answers are we going to get out? You're going to get 4 answers. This is good to remember because I'm going to give you some that are to the 6th power. And if you don't get 6 answers, it means you didn't factor something that you should have, like you left something off. Okay, so if you look at this one, is there a GCF I can take out? There is not. So what are we doing? We only have 3 terms. What are we going to do? Factor. So I'm looking for factors of 12 that add to negative 8. Negative 6 and negative 2. Does everybody agree? So do I. Okay, so we're going to rewrite. I'm going to replace this. So I have 4x to the 4th, and then negative 6x squared minus 2x squared plus 3 is equal to 0. Then we're going to group. What can I take out of the first group? 2x squared. And I would have left 2x minus 3. Everybody agree? what would I take out of the second group? -1. What did I, oh, thank you. Yeah, you can do the other way around. You'll get the same thing inside. And then 2x squared minus 3. Okay, so I bring down 2x squared minus 3, 2x squared minus 1. Now, I'm just going to point this out, just so you are keeping this in your brain. When you get down to binomials, okay, 2 terms, you need to check. Remember on your chart, you need to check, is it a difference of squares? Are these squares, those numbers right there? Or are those squares? Okay, no. So I can't do anything more there. Are they cubes? No. So if they are not, then you can stop and set them equal to 0. So let me show you something on the last one, because I didn't ask you to do this and nobody caught it. Right here. Is that a difference of squares? Is 1 a perfect square? 1's a perfect square, it's a perfect cube, it's a perfect fourth, it's a perfect all the things, yeah? So you could have right from the get-go here done this. Put your x, put your +1 and -1, and then solved. And you wouldn't have had to worry about what happened earlier is everybody just wanted to say x is +1, we would have lost the root in the process. Is everybody with me? So you can do it from here, or you could have done it from there. But that's not always the case, especially if it's a cube. Okay? In this case, these aren't special cases, so we're ready to just solve and set it equal to 0. So 2x squared minus 3 will equal 0, and 2x squared minus 1 will equal 0. And then we're going to solve. Okay. This is going to be 2 answers, right? Plus or minus. And I cannot leave my square root on the bottom. So what am I going to have to do? Good. Multiply by square root of 2, top and bottom. So what are you going to have left on top? Square root of 6 over 2. So there's your first 2 answers. And then you're going to do the same thing on the other side. Solve it. I'm going to skip a step and just show x squared is equal to 1/2. Square root. Rationalize the denominator. Get rid of that rad. What will that be on top? Or what do you do to rationalize it, I guess? Yep, multiply by rad 2 over rad 2. So what does that become? Rad 2 over 2. How many answers did we get? 4. Are those answers real solutions or complex solutions? What would you have to see if they were complex? A negative in the square root, so you'd have an imaginary, right? You'd have an I in your answer. So will that cross the x-axis 4 times? Yes, it will. Okay? Anybody have a question about that? All right, we're going to skip this one because it's identical to the other 2. So if you can do 1, you can do 2 of them. I want us to go back to the story problem because I'm going to show you another type of polynomial function that you might see to solve, okay? So this one says if the small cube, so we're talking about a cube here, if the small cube is half the length of the larger cube, so I want everybody to notice they're letting the sides of the small cube be x, all right? They're letting the large sides be 2x. Why does that make sense? Good. It's So it's just the reverse of what they're saying. If the small cube is half the large cube, that means the large cube is double the small. Okay. The figure is 7,000 cubic centimeters. What should be the dimensions of the cubes? So let me ask you this. What does that 7,000 cubic centimeters represent? Volume, how do you know? Very good. Cubic tells us we're taking three things multiplied together, which is length times width times height, which is volume. So how can I set up an equation to figure out that missing the small ones? Anybody have an idea? Wiley? Not quite. Do you mean like that, 2x cubed? What's the problem with that right there? I didn't multiply the 2, right? So I have to say I want to take the length, the width, and the height. And again, I'm just trying to figure out this part right here, all of this. So do you have an idea, Maria? Yeah, minus, very good. And what would that equal? Yes, good. Because the whole thing is 7,000, so we got to take the big minus the small. Okay, so let's solve this. So what would 2x to the third give us? Not 6. 8, right? 2 to the third is 8. 8x cubed minus x cubed is equal to 7,000. Okay? Now what can I do? What do you call that? Okay, we could start there, but what's the problem right now? Well, an 8's a perfect cube, so that's not the issue yet. It's not equal to 0. So what can I do first? Okay, maybe not yet. What else can I do? What's 8x cubed minus x cubed, people? No? Thank you. What's happening here? We lost what we're doing here. Okay, combine like terms. 7x cubed, which means I can do what now? Correct. Divide by 7. So x cubed is equal to 1,000. Now, this is kind of like what I was talking about before, where some of you right here will stop and you will cube root it and you'll call it a day. And here's what I'm going to say. If you were doing this and I'm asking you to find all the zeros, okay, then the piece that you would miss is you would miss the part of, if it is a difference or sum of cubes, then you would miss the trinomial part of this. So here's what I need to know. Is 1,000 a perfect cube? Okay, so then let's bring it over to the other side. So we would subtract. And now we have a difference of cubes. Does everybody agree with that? So let's do that. So let's do our difference of cubes here. So we have our binomial and then our trinomial. We're going to set it equal to 0. So what would go in my binomial? X minus what? 10, good. And then in the trinomial, I would have x squared. What comes next? What sign? Plus, good. This is a plus. 10x plus 10 squared is 100. Good. Okay, now, what did I tell you about this trinomial? Cannot be factored. If it can't be factored, what can you do to still solve? Quadratic formula. Very good. And this is what you would not get if you would have just tried to cube root from the top. Okay, so I'm going to go ahead and bring this down. I know that x minus 10 equals 0, so I know one answer is, what is x going to be? 10, okay. And then over here, I'm going to do that quadratic formula. So x equals negative 10 plus or minus the square root of parentheses 10 squared minus 4 times 1 times 100 all over 2 times 1. Help me out here. Inside here, somebody shout out what you get once you get it. Negative 300, okay? So I'm going to go ahead and rewrite this. Negative 10 plus or minus rad negative 300 all over 2. Then let's do the square root. What do you know you're going to have that you're going to pull out? An I. So I know I'm going to have an I. Is 300 a perfect square? Okay. So let's break it down. I'm going to do 103, and then 10 and 10, 5 and 2. So what does rad 300 become? What? 10 rad 3? So 10 goes on the outside, rad 3 goes in, or 3 goes in. Okay, so I'm going to rewrite again. Negative 10 plus or minus 10I rad 3 divided by 2. Anything I can do here? Yeah. Yep. Divide all of your numbers not underneath rads, all those coefficients, divide by 2. And so we get negative 5 plus or minus 5I rad 3. You could say over 1. You don't have to. Okay? Now, how many answers did we get right here? 3. Does that make sense? Okay? Is there any problem that you see? Why are you asking if it should be imaginary? Can the dimensions of a cube be imaginary? Cannot. Just like time can't be imaginary, right? So this will not be a final answer for the story problem. Now there's a difference here. Me asking you to solve a polynomial function and me asking you a story problem, does everybody see the difference? So if I just gave you this and said, find all the zeros or all the solutions, you better have 3 written down. Now, if I say, what are the dimensions of the cube, then only give me the one that makes sense. Okay? Is everybody understanding this? So I'm going to say this again because I don't know if it rang, if anybody got it up here. For those of you that want to automatically stop in cube root, if you do that, you are always going to miss your imaginary solutions. You will never get them. Okay? It doesn't work like that. So you're never going to see us cube root to get a solution. If you're doing that, you're not listening or following the process of what we're doing. Got me? Okay. Anybody have any questions on solving? Okay, here's the last thing. So I want to make sure you know how to do this. The other piece is, can you write a polynomial function that has these given zeros? Meaning, these are like all my answers. So like at the very end, I would be getting out x is 3/4. X is 1. Okay? So I'm asking you to sort of think backwards. How could I work backwards to try to set up the polynomial function? So let's just go one at a time. Let's just start here. If this was x equals negative 2, what did the step before it have to look like? Does everybody agree with that? That would be x plus 2 equals 0, right? So it looks like that in factored form, right? Okay. What would this one have looked like in factored form? X plus 0, which is just, yep, could just have looked like that, right, in factored form. What about this one in factored form? X minus 1, good. Okay, now think this one through a little bit. Don't say to me x minus 3/4. So work backwards. If I had you work backwards, what would you do with that 4? How would you get it to the other side? What would you do to it? You would multiply, right? So if I was trying to get it to the other side, I would multiply. So then I'd be here. And then how would I get that 3 to the other side? I would subtract. Yep. Okay, so now I have 4 sets of parentheses. How can I figure out what that polynomial is going to be? What does that mean? What? Well, they are in groups, but what can you do? If they're all side by side, squeezed together, what do? Yeah, you're just going to start multiplying. This is what you did yesterday. Multiply them all together. And then you'll have your polynomial once you combine like terms. So we're not going to do that because you can do that. And then you can either set it equal to 0, or you can set it equal to, like, whatever, f of x, or set it equal to y. It doesn't matter. Pick something to set it equal to so that it's a function. Okay? Anybody have any questions for me? Yes. 10, and then the negative 5 plus or minus 5i rad 3, but then we marked that out because it can't be imaginary. I'm just showing you because on your homework, it's not going to be a word problem. It's going to be an actual, like, solve and tell me the zeros. So I wanted you to see how to do it. Yep. Yes, you could have stopped because you would know. Yes, so this one, when you do the sum and difference of cubes, you're always going to have to do a quadratic formula. Yes, yes. Okay, so your homework is going to be a worksheet that I've created. I want you to, you'll work on it. I want you to keep it and bring it next time. And we will go over the answers when you come to class. The front side is going to be, the first 6 is going to be all factoring. And then from there, you're going to do solving. And there are a couple story problems on the back. You're welcome. Once you multiply it all out, I don't know, something x to the 4th. Do you want me to do it? I mean, I'm not going to be able to do that in my head. So if you can, then kudos to you. But, like, I'd probably go ahead and do this here. And then I'll do this one. And then see. That's what it should look like if you want to write that down. Oh, I just saw this on the back. Turn to the back side. Look at 14. If one of your zeros is a 3i, what does that mean? Yes. Okay, so it's going to be the square root of a negative something, right? So does anybody have any thoughts about this? And how did you know that? Okay, so it would have looked like this originally, right? You'd have an x squared to be able to have to square root it. So what would that equation look like if you, so get rid of this now, and you take that to the other side? How do you move negative 9 to the other side? You would add it, right? So this is what it would have originally looked like. Does everybody agree with that? Now, if you are confused about how to do that, then here's what you could have done. What does it say those roots were? 3i, what else? What are the other ones? And 4/3? Okay. If it's hard for you to think backwards, then you can just do this. You can always just do x minus the root. So I can do x minus 3i, x minus negative 3i, x minus negative 4/3, x minus 4/3. You're just going to have to do more work with fractions if you do that. And so here's what could happen. For this part, for those of you that struggle here to think through that, then just FOIL this and you're going to see how it'll work. So you would get x squared. X times 3i would be positive 3ix. X times negative 3i would be negative 3ix, right? Those are going to cancel. It's going to go away. And then negative 3i times positive 3i would be negative 9i squared. Yeah? What's I squared? Negative 1. Negative 9 times negative 1, positive 9. So this represents 3i and negative 3i. And so, again, if you conceptually cannot picture what would be under the square root, then just do this to figure it out. Just plug it in and FOIL. Okay? All right, I know this is a lot, and it's all new. I promise you it's just going to take practice. So you're just going to have to practice to be able to see a lot of these, to be able to get the feeling for this. We're going to review, so unfortunately your review is going to be online because Tuesday we won't be here. I will post the solutions to the review. Ask me questions if you have them because we are going to quiz when you come back on Thursday. But you hopefully will get enough practice in that you'll feel pretty confident. But message me if not, okay? And I will also post the solutions to this worksheet in your module on Tuesday so that you can at least check and see if you're getting it right or not. Because if you don't know if you're getting it right, you're not going to have any idea what to ask me. Okay, so you have a few minutes if you want to put your stuff away.